Other one.
Oh!
Top draft short.
Bloody hell, proper stuff.
That's what I was getting when the dog decided to empty his.
What I do want to know though is why is there different coloured speckles in this one? Is that because that's how it is, or is it because somebody's put some dregs in it? Ah, I see.
I believe you might have been the one who got blamed for that.
It was not me, I can assure you. I'm not surprised I'm the one that's blamed. Any sort of coffee-based misdemeanours and I'm the one. Right, okay. Let's make a posh coffee. So, on this week's episode of Making Coffee Badly, ooh, look at that.
Brown.
Some of that goes in. Why am I advertising Vauxhall and not using one of my own mugs? It's probably even like another dealership or something. Hey, use somebody else's garage.
I was going to say, I didn't realise we were also fucking with the Vauxhall main dealer.
Yeah. Right, a spot of milk. Let's try and get this over with because I'm sure a full episode of making a cup of coffee is not going to be everybody's cup of tea. Right, let's go. So, what are we on? 99. Oh my god. Episode 99 of Retropower Uncut. Which perilously means I've got to somehow fit in 16 or 17 interviews between now and next week. John, can you just turn the music down? What I will start with, we'll creep round this way. What I will start with mentioning is that we had some awesome visitors to the workshop. Oh God, the dog's going nuts. We had some awesome visitors. This weekend just gone, it was the VBOA, so Vauxhall Bedford Owners Association Club show, which is one going back a number of years we were involved with quite a lot because some of our early builds were Vauxhalls and Opals. And actually our very first sort of full build, as I would call it, was an Opel Ascona for a chap called Kurt. And then actually that was followed not long after by another build on another Ascona for his mate Jason. And they were at that show, so they both came around here the other day. It was awesome to see the cars, awesome to see them. Great just to see the two cars out and about and on the road. Yeah, Kurt's particularly sticks in my head because we finished it in 2011. Obviously, it was as I said, it was our first major build, but finished it in 2011. So it's actually, what does that make it? 11 years old after our rebuild of it, and it still looks absolutely stunning. I mean, he does obviously look after it, but looks incredible. And yeah, he's still enjoying it as he should be. So yeah, great to see those guys. I'm going to start with the Land Cruiser. So. This has generally been fighting us, actually. You would think putting the body together on this would be dead straightforward. And it ought to be, and we knew it was all mocked up at metalwork, but we were battling a bit with the fact the front end seemed low, and we thought, well, maybe it's the shimming of the body to the chassis that's wrong. Kind of thought, well, it can't have been because we know the shims they use next door. We wondered if maybe even the chassis had warped, but it definitely hasn't because we've done some checks on that. So we revisited the body shims, and yes, sure enough, if we took, it wasn't even a lot, I think it was an extra 5 mil, probably not even that, 4 mil maybe, on the frontmost body mounts, and then the relative height increases working your way to the back. That was all it needed. In my mind, with it sort of pivoting on the back bumper and having that height difference at the very front of the main body, that would make very little difference at the front here, but it certainly made enough of a difference. So yeah, thankfully got to the bottom of that. Resolved that situation. We just tweaked out the holes in the very back mounts to give us a little bit more forward on the body to tighten up the gap between the main body tub and the upper part of the front wing, just to get that a little nicer. But nah, we've had it all mocked up, happy with the fit now, but everything had tape on it to protect it. So Adam's just going through now and basically doing the final build-up of the body panels without the protective tape. We have put helicopter tape, as we call it. It's like a thick, clear, protective tape on wherever there's mating faces, so particularly on the underside of those upper wing sections where they meet the lower wing, just to stop the paint chafing. So yeah, I'm very, very excited to actually see this all together for the final time rather than just kind of a trial fit. We've done a few other details on it, finished the battery wiring, that had been routed down the chassis, but that's now all terminated up at the front. Comes down the chassis, goes up to a stud we've got on the bulkhead that passes the power through the bulkhead to the PDM on the inside, and that's also where it then splits out to the starter and the alternator. We painted a few bits, so the brake master cylinder was just a bare cast iron unit, so we only spotted that after we'd put it on, and we were like, actually that's probably going to rust with time, so took that back through, put a paint on it that we often use on bare metal things. It's Celimix Direct. It's basically a direct to metal polyurethane based paint, which is great for little jobs like that. So that's that. Adam's got the radiator mounting surround and the aircon condenser on, with a view to some of the next steps there. So on the radiator, we're using this original one as a mock-up. We're going to mark on where the revised positions will be for the top and bottom hoses, and we're also going to make a modification to the bottom tank, because on the final one we're going to put an oil to water heat exchanger in there for the transmission fluid cooling. So we'll do some modifications to this, use that as a mock-up unit, send it over to Concept Racing, and they'll do the alloy one, which will have everything in the right place. It'll have the fan mounts on the back, and it'll have the heat exchanger connections for the transmission cooler. Speaking of Concept Racing, the fuel tanks are basically done. There was one detail on them because they're actually quite a complicated shape. We had to do really complicated sort of technical drawings for the tanks because it's all irregular shapes and angles. And one that was very difficult to do was the positioning of the filler neck. It's quite difficult to explain the positioning of a filler neck in a drawing in free space. And we were worried about it being exactly right. So what we got them to do was actually build the tanks other than welding in the bottom panel on the tanks. Send them over to us. We've trialled them in there. The tanks fit fine. We've then cut and marked out the neck, so marked all the orientation with tape, sent it all back to them so they can now weld up that neck. We'll know it's be in the right place. We also marked the orientation for the link pipe that joins the two tanks for filling them. They're going to weld those on, and then the reason they left the bottoms unwelded is because they're going to be foam filled, and once the foam's in there, with no means to kind of pull it to one side, you can't really then weld because it'll melt the foam. So leave the foam out, weld the necks in, then foam goes in as the last thing. That can be pulled to the top of the tank through the pump aperture, and then they'll weld the bases into the tanks as the last step. So I would imagine we'll have them back next week, and that will allow us to get the rest of the fuel system in. John's done some of it already. He's done the plumbing to the regulator from the bulkhead mount on the chassis, and then through to the fittings that come up through the floor of the body feeding to the tank. So yeah, looking good on that really. As soon as those tanks get in, we can complete the fuel system. We'll be able to finish the oil system once the radiator's done, also the cooling system. Yeah, it'll start coming together at that point. So that's where we're at on that. Project Utah, you may have noticed as I walked through, is back in the building and has been enjoyed by the owner. He's now done what I suggest, basically 500 miles as the first stint with the new owner, and then it comes back. During that 500-mile stint, I advise they kind of keep a list of any little snags, things they're not happy with. I obviously cross my fingers that nothing major goes wrong, but nothing has. It's been absolutely spot on. He really enjoyed the drive back up here. It's now showing, I think, about 680 miles on the clock. And we're going through the snag list basically. So you probably noticed straight away, one of the things is the tank on the bulkhead there, which is screen wash and breather, has been removed. That's because we were getting a little bit of kind of water/oil vapor around the cap on the top of the tank, which was just looking a bit unsightly. So the cap on the tank's vented, and that is where the engine breathes out. But it was carrying a bit of vapor with it, which was then condensing on the top of the tank. Probably not helped by the fact, because the tank's got screen washing as well, it's kept quite cool by that, so it's almost like a condensing tank. So we're trying to come up with a way of knocking more of the vapor out of the breather emission. And Jim's come up with like a little baffle insert that goes into the tank, forces the returning vapor to go down and around the bottom of the baffle, and then it also has a little recess in it that we're going to put some filter foam in there, it'll be tank foam, so it's oil resistant, so it'll be forced kind of down around the baffle through some foam, and we're hoping that will knock enough of the moisture and oil vapor out of it that the remaining emission will be more or less dry, so you won't get that slight kind of moisture staining on the top of the tank. So that was one detail. There was a rattle in this door, which James has just tackled. We're basically just working our way through. The DAB signal's not very good, so we're going to change out the DAB aerial. The join in the boot seal was just kind of open. It was never glued originally, it was just butted up, which we didn't realise, and with the boot opening and closing a few times, it had opened up a small gap, so that's been glued. So it's basically details like that that we're just working through. And obviously now it's done its mileage, we're going to go through and do a full spanner check of everything and make sure everything's still tight and that we're happy with everything. And then it'll go back to him. So that's why that's here. We'll try and mosey through this gap here. I actually forgot to mention on the Land Cruiser, another of the jobs that we've been tackling, well, there's a couple of things actually, the door hinge painting. So I showed, I think last week, we just got back the stainless steel front door hinges we had machined. A while ago we got the rear door hinges through. We did a trial build-up of those on the car, happy with the fit of everything, but we want them to be body coloured with then black Xylan fasteners, which then presents another challenge because we've got to paint them, but in a fashion that doesn't get damaged when we fit the bushes, or paint them with the bushes in situ. And we did think originally we were going to mask where the bushes go, but because they're oil sort of filled bronze bushes, the masking doesn't really stick to them. So that ruled that out. And then also we realised on the central part of the hinge, where the bushes bear on it, we couldn't really paint that because the paint would come off straight away. Now obviously it's stainless steel, so it doesn't need to be protected from a rust point of view. So we sort of wanted to mask a little circle the same size as the bush. And I think it was Mark came up with quite a good idea of basically threading them all onto a threaded bar with round tubes sandwiched between them, which is also a good way of holding them, because that was the other challenge, is you can't hold them through the bolt holes, otherwise you end up with a little bare bit on the hinge. So we've kind of killed two birds with one stone, threaded them onto a threaded bar with tubes between, and they not only mask the areas where the bushes are going to sit, but they also hold them on the pole securely for painting. So that's good. And the other thing I'd forgotten on that was the fuel tank mounts. We got back from Bruce, who's done the engraving on them, so, sorry, the fuel pump mounts. So they're these machine caps we had made that go onto the top of the fuel tank, and they hold the in-tank pump in the tank, and have it's also where the pipes and electrical connections pass through. So they've been lasered with kind of inlet, outlet, vents, positive, negative, for all the various connections that are on them, and they look awesome. So I can't wait to get the tanks back so we can put those on. Right, moving on from that, Stratos. We're kind of on the big push, I'm hoping, to actually get this certainly drivable and shaken down on a test track, if not fully completed and handed over. John's just going over some spanner checking at the moment. We did a change on the rear. We've been puzzling for a while over why the rear wheels seem to have a lot of negative camber, even though they were pulled fully in on the bottom. And now we thought, there must be some adjustment on the top. Took the cowls off, and yeah, there is adjustment on the top, slid them out fully, still had loads of negative, and then we realised that there's like the billet plate that holds the top of the strut is actually very slightly offset, so you rotate it 180 and it pulls the strut further out. So we resolved that anyway. I've been fitting the rear clam latch release cables, so there's one of the few Fiat X19 parts that still remain on this is the little handle that sits in the door shut area. Pull those, it pulls the cables which release that rear clam. So I've been fitting those, and it's just going through little jobs like that. We're going to refit the rear lights, get all the rear wiring back in, which was removed when we did the repaint on the rear clam. There's various refitting to do on the interior. We've got to finish the upper bulkhead. With that done, I can get the harnesses in, bolt the seats in for the final time. Headlining's done. So yeah, it's really small stuff now. I'm going to get the wiper arm fitted and the washer spray bar that fits to it. So essentially we're counting down to a track test session, which I'm hoping will be in probably 2 weeks-ish, at Bicester Heritage, little test circuit they've got there. And then after that it'll be the scary countdown to IVA and the changes we'll probably have to make. I think the emissions will be the hardest one on that, so watch this space on that. James was off last week, so there wasn't any more progress on the E-Type, but we'll pick that one back up next week. George, who's literally in the process of trial fitting the column shroud for this, so that's been the bulk of his work for the last few days. I think he was just scanning that whole column area last week. He's now finished the design of that column shroud, done a 3D print of the lower one. The top part of it's about to go on to 3D print. we've just offered that up and it's all looking good. I think we might make a slight revision, and that's the beauty of the 3D print, that actually once you've done the design work, the manufacture of the parts relatively cost effective, I should say, not free. So yeah, it looks great. The only thing was the column, it looks like you've got to shift where the switch gear, which mounts the shroud, attaches to the column itself. It looks like that needs to be pulled very slightly out, because at the moment, and he hadn't spotted this before, the horn contact, there's like a springed brass contact that touches the back of the boss. It's actually just a few millimeters off the boss, and when you move the thing far enough up for that to contact, it then opens up a little bit too much of a gap to the dash. So we're going to make a slight revision and reprint that. Then do the upper shroud, and we should be good on that. Overall design looks great. Big one on this, finally, the tanks that have been machined. So the screen wash / power steering tank this side and brake fluid, clutch fluid tank on the other side. They came back from being machined. Very quick offer up to make sure they were right. We did the drilling and tapping on them for the unions that go in the bottom, just because the guy machining them was a bit pushed for time. Hence why they've taken this long to get here. And they've gone straight out for anodising. So they've gone along with things like the glove box infills that we've done previously on this, various other things, the little mirror corners. So when we get that lot back from the anodising company, should be early next week, I'd have thought. That opens up loads on this then. We can do the full door builds, get the glass in. We've got, in fact, that's another thing, we've got the custom glass back for this now. So we'll be able to crack on, get the door builds done, all the window regulators, glass in, those little billet corners, get the frames on, get the mirrors on. Then once we've bolted the tanks into the engine bay, everything behind the dash can go in. So that's like the PDO and ECU mount this side, complete all the brake plumbing there, get the heater and aircon unit in this side, get all the pipe work in for the demist vents, dash vents, get the instruments in the dash, then we can fit that lower dash section for the final time. And that basically is the cornerstone that then leads to everything else being possible. We'll be able to we can get the headlining in. Well, we could do that now, in fairness, but everything else, the carpet, the trim panels, everything else really hinges on that. So looking forward to making some big progress on that. Another thing on this is the fuel filler neck, which we showed previously. That's gone for anodising, so that can go on. That'll complete the fuel plumbing. So yeah, quite a lot of exciting sort of getting towards completion jobs all around, really. On that note, I'm going to hand over to Nat and show you what's going on in the metal workshop. And I'll see you next week or maybe the week after, for the 100th episode. Only the reason I say that maybe the week after is that I think Nat's got a autofocus episode in store for next week, so watch this space. Right, well, thank you, Cal, for the handover, and here we are in the fabrication shop for another week and another Uncut episode in here. And I'm leaning on one of the partially welded rear turret assemblies for the Project 1 Escort, so that's where we'll start. You may remember from last week that we had a little spectacle jig on this bench with a pair of these sections, which are the 3mm thick steel top and back, if you like, or outer part of the rear turrets. They were the wrong way round on a little jig on the table on here. Well, they've now been put the right way round, and I've then done a little bit more CAD work on drawing up the bit to allow that spectacle jig, as I would call it, to be allowed to be fitted to the select jig bed within the Escort around the rear subframe, so that we can hold these strut tops independently of this surrounding part of the turret. We can hold these strut tops at the correct height, the correct fore and aft position, and the correct lateral position within the car, to make sure that we have the rear suspension geometry correct relative to the rest of the rear frame. It's one of the benefits of using a really obvious benefit of using the jig bed, the select jig, is that we have one rigid frame that we connect all of the parts to, so that we know that they're all correct relative to each other, as long as I haven't made any silly mistakes in the CAD, which I don't think I have. I hope I haven't. I've done some sensible measurements on the car as well, with everything in place, just to check, because it always pays to do that, because it's easy to make mistakes, particularly when you're coming on and off a job all the time, because obviously we've got lots of other things to do, like running the business as well. So that's where we're at with that, and I've just put some MIG tacks around the inside of this,
I've shaped this, once I've drawn, sorry, I'll rewind a little bit there. Once I've drawn these turret tops in position, got them on the jig in CAD, I then did a little bit of a fusion. One of the limitations on Fusion 360, the CAD package that we use, is the sheet metal. And I suspect it's a deliberate limitation so as not to eat into sales of Autodesk Inventor. But generating sections like this, it's part flat, part round, and not a particularly complex part, but it's not really designed to fit into the normal sort of flange sequence in that software. So I can generate that part as a sheet metal part with a little bit of a workaround in the software. But the problem comes when you try and unfold it and the software can't really, unless I'm missing something, and I'll be really happy to be educated on this. But as far as I'm aware, the software can't really work out how to unfold a big radius with a flat either side of it. What it does is either not unfold it at all, or it unfolds the big radius, but then puts the same radius onto the flat sections and kind of rolls those around by the same radius as that. So I can't generate the flat pattern. I did a little workaround anyway to generate a flat pattern from that by chopping up the two options of flat pattern I could generate and putting them into another DXF file. So it didn't really matter. Anyway, long and short of it is I generated that as a CAD file, as a DXF file, so that I could cut it on the CNC plasma and get it all nice and accurate. It would be quite easy to do it manually. We could cardboard template it, obviously, or another option would have been just to have rolled it at the full height and then just trimmed it off. But I didn't really want to do that. We've got CAD for a reason. All the bits that it's got to connect to are already drawn there. It makes sense to just draw it in CAD and cut the exact bit we need. There's a trim to be done at the bottom, but this is done long enough because for it to be able to link into the rear subframe mount. This is the turret for the offside rear on the car, and the rear subframe mount actually bolts in here, the bush, and the forward half of the mount for that bush is actually the lower part of the turret. That will be heavily reinforced with a spot welded reinforcer plus a boss on here, and then the forward half of that mount is actually the bottom of the turret. These weld into the back of the inner arch tub down both sides here. That welds into the top of the arch tub. The arch tub comes up round here. That welds into the top of the arch tub, and then the replacement parcel shelf will sit pretty much on the top of here, and then there'll be another reinforcer that comes up off the top of here to bring that up level to the parcel shelf and tie the top of the turret into that. And then there'll be an access hole in to get at all this, to get at the adjuster and get at the top and the bolts, and then that'll have a nice cover over it in the parcel shelf. So that's how all that sits in the car. That's all going to be fully welded on the inside and then dressed off on the outside so it all looks neat. So that's where we're at with the turrets. When I mentioned the parcel shelf, that then leads me on to another little job that's been done this week, is plasma cutting out, just rough plasma cutting out the original parcel shelf. That's all going to be trimmed up, and then we fabricate a new one. I'll be fabricating a new one that sits on the lip of the original parcel shelf, and as I say, that all being well, the heights look about right for that to tie into the top of this. On Gordon's car, these were actually lower because, long story, but basically the actual centre lines are slightly different between Gordon's car and this car, because this car's going to be running bigger diameter wheels, which somebody mentioned, oh, but you just run lower profile tyres and it won't change anything. It does change it. 15-inch wheels, even with the lowest profile tyres, are still bigger than the 13-inch wheels with the, I think they were 55 or 60 profile tyres that we ran on Gordon's car. It means that the actual centre lines do need to change in the car for the wheel diameter change, and consequently the strut top mounts have had to rise in the car a little bit, the subframe mounts have risen in the car a little bit. And because of that, the gap between this and the parcel shelf, there's only really one place to put the parcel shelf, and that gap's going to be changed. On Gordon's car, this recess was quite a lot deeper. It was about, off the top of my head, I haven't actually got a drawing for it, but off the top of my head, it was about 30 mil deep at this point, and well, I'm guessing, looking at that, probably 75 mil deep at that end. It was quite a big well recess, and we had a folded section that went all the way around here and actually supported the parcel shelf and tied everything in. And on Gordon's car and on this car, we will then be running a tube, a piece of roll cage tubing across between the inner quarter panels, welded to a spreader plate there, which will pick up on a gusset off the front edge of the turret here, and then go across, pick up off the other turret, and then pick up onto the inner quarter panel and be gusseted into the inner wheel arches, the inner arch tubs as well. So it ties everything together incredibly strong, and then that also gives us our upper seatbelt harness, like the 4-point harness mounts. The car will be fitted with 4-point harness mounts, but also inertia reel seatbelts. Harnesses are a pain on the road. Inertia reels are much better on the road, but if you want to do a track day, you really want the harnesses. So we make provision for both. Gordon's car was the same in that respect, had inertia reels, but provisions which were all plugged off neatly and hidden, but it had provision for harnesses. So again, if it's used on a track, it's easy enough to swap it onto harnesses, and that'll be the same on this. The car's having a rear half cage in this, just for a little bit of safety on track days when it does track days. So that tube going across there will then also tie in via the rear diagonals onto the main hoop, and I'm going to try and do the main hoop to sit pretty much welded directly into the shell, so it's absolutely as tight to the shell as I can get it. So watch this space on that one. You'll probably see me making a mess of it, but I'm going to try and get that tubing so it's almost part of the shell, just to get it right out of the way, because we don't really like the cage moving into the car. It just gets in the way and looks ugly, so I'm going to try and tie that right into the shell, right out of the way. So that's all to come. And then obviously also in the car, I've also cut out the back of I'll get there in a minute, the arch tubs, the vertical face of the arch tubs. Seems strange to put a load of metal in just to cut half of it out again, but because there's a bit of tolerance shuffle going on, it makes sense to actually put all that in and then cut the piece out for this once you've got the jig to dictate exactly where these go. Put the jig in, then I use a laser to cast off the sides of the jig, cast a line onto the inner arch tub, then I can cut the inner arch tub out exactly in the right place. And that cut also goes completely through the chassis rail in the back here. And we build a new rail that actually goes around the base of the turret and ties the two ends together. There's very little load on the rear section of the rail because it's no longer carrying a leaf spring. All it's doing is carrying the boot floor and the rear panel effectively. So it doesn't really do a lot, the rail behind there anyway. But we build a new rail, which the inner face of it is the turret, and then there's a section, it's boxed off the back of the turret, which goes around the turret and ties the rail together. So it just puts a little deviation in, which is also tied into the rest of the turret and the floor. So it's incredibly strong anyway. In terms of material thicknesses, as I said, the top is 3mm. This is 1.5mm approximate. It's actually about 1.4 this sheet, because they always seem to float around tolerance-wise and always be a bit under thickness. So that's 1.4mm thick real thickness, and that's just under. That's about 2.8 real thickness. That's that. As I say, there'll then be some, with all the reinforcement on the top. The strut tops are incredibly strong. Once it's all tied together, the whole setup is really strong, really rigid, and locates the suspension extremely rigid, well in the shell. So that's all coming together nicely. You'll see over there my little my improvised former for shaping this. I was looking for something about the right size, and there happened to be a scrap gas bottle kicking around that I might have found in the laying around in the scrap. So that was pressed into service, literally, in the press tool to shape this. It was about, I think it was about, I forget now, 5, 6 or 7mm undersize on diameter. So allowing for spring back, it was exactly right to use in my little hydraulic press adaptation to do the shaping on that. The way I've done them before is generally with the folder and bumping on a lot of little tiny folds all the way around, because it's almost impossible to roll this really neatly anyway without obvious starts and stops. Whereas you can put it on in the folder quite neatly, but you still do get these little flats where all the folds were, even if you're very careful with it. You could do it with the rubber wheel in the English wheel, bit time consuming, whereas that, with a suitable diameter former in the hydraulic press, it's sort of 5 minutes work to actually do the final curving on that. So that's worked quite well. And I think that's pretty much where we're at with Project 1. So we will move over to the Churchill Jaguar. I'm going to hopefully swing the door shut. Yes, I can swing the door shut, just so it's not in the way. And here we can see the quarter panel coming together. I can't actually remember exactly where we were at last week, but the main focus for Stu this week has been welding together the various sections. You'll have seen over the last few weeks that this quarter panel was made up of a number of pieces with various welds, all for good reason. With a bit of tweaking, Stu's now got all that tacked together. And he's tacked it roughly on the car, pulled it off, planished those tacks up, checked it all, done some tweaks, put it back on the car, rechecked everything, located it all back on the car, screwed it all back on again, put some more tacks on. You can't planish the tacks on the car for most of the welds on this. They're in the way, they're hidden. So he has to rough tack it, take it off, planish those tacks, put it back on, check it all again, because it will actually move quite a lot after those first few tacks. Once he's checked all that, take it back off again, put more tacks on, then put it back on, recheck it, take it off, planish those, and so on and so on. So putting the tacks on has been quite a convoluted process, because basically you have to take it off to planish them, but put it on to check that the planishing hasn't moved anything too far. Once he's done all that, happy with everything, then put it on the bench, fully welded it off the car, planished the welds up, re-stretched all the welds back up to where they should be, put it back on the car, and now it's the beginning of the long slog of, while we can still take the panel on and off, going through metal finishing it. And you can begin to see, because he's put a dusting of black paint on this, so you can actually see where he's going, you can see the highs and lows from filing it. He'll file that to expose all the high points, but that's where I'm guessing I'm talking as if I'd expect everybody to know these things. Basically, you would use a body file which has no flex to it. If you use a sanding block, that'll look dead flat. But if you get a body file which has 0 flex to it, and set it to, if you've got a curvature, set it to the correct curvature. If you have it, or if it's more or less flat, just use it flat. Then run the body file very lightly over. You don't want to be taking too much material off, but you just run it lightly over after putting a dusting of some sort of colour. A lot of people use engineer's blue. We just use a dusting of black paint usually. Put that on, then run the body file over it. It exposes all your high spots and your low spots more relevantly. Then you can, using a combination of tapping your high spots down, tapping the low spots up, you can keep raising and lowering sections of the panel to get it all an even curvature, all an even shape. Obviously Stu's indicated areas here. This weld we knew was going to drop. This section had dropped actually before it was welded. So we need to pull all this section out anyway. As you can see, the mark Stu's put on here, we had a bit of a game there. It had already pulled in before it was even welded. We knew it would pull in anyway, so there wasn't much point trying to correct it too much beforehand. You've just welded it, let it pull in. That's all going to be planished up. There's quite a bit of stretching to do there, which is what those marks there are, because that whole area there, we weren't quite happy with before it was welded. That all needs to lift up and pull all this section out so it blends properly into that. So there's going to be quite a lot of work, but you know, there's a good number of hours of work just planishing that area up and getting that the correct shape. Then obviously, as you can see all around here, there's quite a lot of work getting all these beautiful shapes that were neatly done on the Pullmax or the Pals Nibbler. As soon as you put any weld near them, they all move. So once you've done that, you then have to planish them all and reshape them all and get them all correct. And then there's an area that's actually very close to correct now. That area there would be an area that we would say is suitably finished. We would say that that's pretty much finished. The highs and lows on that now would be taken out with a coat of spray polyester surfacer. We don't use high build primer. I think we've mentioned this in videos before. We don't use high build primer at all because basically we can't find any. In all the high build primers we've used, we can't find any that don't sink, that don't drop with time. They all have some solvent content, and the solvent content always seems to cause them to sink. Usually at an inopportune moment, usually after the car's gone back to a customer. So we just use polyester either in a normal filler, body filler, or in the sprayed polyester form, mainly the sprayed polyester form these days, to take out these undulations that are still left there. I mean, when I say, you know, they are tiny. That's running a body file over that. That's a low that the body file's picked up, but that's a very fine low. It's not deep. We'll take, but the sprayed polyester would easily take all those out. There will be people say, oh, there's no filler in this car, there's no filler in that car. There's an awful lot of rubbish spouted on the internet about that. Yes, it is quite possible to do that, and we'll see something in a minute to that end. But the fact is, when we're doing a one-off car with panels like this and making the panels once, we're not doing a prototype panel and then doing a final panel, inevitably there will be some product, some sort of something to give us some build on the panel to sand back to take any of these undulations out, because the cost of getting them out in the metal in terms of time is just enormous, absolutely hundreds of hours just to take a myriad of these dents out. It's a very time consuming process. So we'll try and get all of the panel work to look pretty much like that. And then we know that then once that goes into Gaz's area and we start the body prep on it, that we haven't got too much. We've got a lot of work to do. We haven't got an excess of work to do at that point. Once the panels are correct like that, while they're still screwed on and pinned on, as they are at the moment with these Cleco fasteners and the Tech screws, then these are going to be spot welded on. These are going to be spot welded here because these are, and then leaded, because the trims are going to be going down here, and that actually hides this section on the body shell. So we're spot welding those on, which will enable us to not have a distortion problem along the final weld lines there. It'll be plug welded to the sill, plug welded up the pillar. It'll be spot welded to the finisher that comes up here that caps this section off, which Stu's already made. It'll be seam welded on the ends, spot welded down here, all the way round. There'll be some lead in the various areas where that's got to blend, and it'll be seam welded down the back to the rear panel, and again there'll be lead in various areas to smooth those sections out. All of the panel joins on this car will be lead filled pretty much as they were on the original Jaguar. Anywhere where you've got a significant degree of fill required, we would generally try and use lead because it doesn't sink, it's completely rigid, it's completely waterproof. It has its downsides, but the plus side is it's pretty good in terms of how you leave it is how it stays, basically. So that's pretty much where we're at on Churchill. There's a lot of planishing, metal finishing, tapping and filing work to be done this quarter, the quarter the other side. Both the doors have got to be done. There's a lot of metal finishing to do on the doors, as I mentioned before. Then there's metal finishing to do on the roof, so there's going to be a big slog of lots of us wearing ear defenders and Stu hammering things. So that's where we're at on that. Then we'll move on to the new recruit in the workshop. We have a new item in the workshop, and this has come to us. This has been a job where the metalwork was subcontracted out. This was a project which kind of belongs to another a customer who already has another car with us, and he asked us about doing some work on this, and we could do bits of it, but we haven't got the capacity in the workshop to do all of the work. And we also know a man, we know somebody who, when it comes to E-type metalwork, is on a far higher level in terms of knowledge and experience and ability, really, to be quite honest, in terms of just everything to do with E-types. Andy Hall, who runs a business called Vintage Machines down near Rugby, in Marton, near Rugby, he has done, I would say, the metalwork on this body shell. That's a bit of an understatement. He's basically rebuilt this E-type. It's a Series 2, 2+2 E-type. And he has rebuilt the body shell on this. There's very little remaining of the original. It was very poorly. The front end was completely scrapped. The entire bonnet assembly was completely scrapped. That's a replacement bonnet assembly. Nearly the entire bulkhead assembly was scrap. Most of the rear quarter assemblies, inner and outer, were scrap. He's made new outer quarter panels for it. He's replaced the inner sections. I have to say I might be slightly ignorant on some of the parts, knowing whether he's made them or purchased them. What I do know is he's made the quarter panels. He's made the car had been fitted with a Webasto sunroof, so he's made a new centre for the roof and then welded that in. And as you can see, that's a pretty impressive job. That's the weld line round there. You would struggle to see it. So that's welded in. Quarters are welded in, they're all planished and metal finished. Replacement doors, there's a tiny bit of work to do on those, but very little really. Most of the rear end has been replaced, other than the very inner structure. Most of the wheel arch assembly has been replaced. Complete floor assemblies, both sides have been replaced, and most of the front bulkhead assembly has been replaced. So most of the car is new really. So this came back to us yesterday, Wednesday. I think that's right, anyway. Yes, yesterday. And we've then started work on that. There are a couple of things. We have been refitting because the floors are completely rotten, the carpet mounts, the little raised, I don't know what you call them really, little metal raised things that the carpet studs attached to were missing. They'd rotted away on the original floor, so there were no locations left for them. The replacement floors don't have them fitted, the carpet sets, some carpet sets have pre-made holes in, but it appears that the carpet sets for these don't. So we needed locations for the holes. Andy wasn't happy to just guesstimate the holes, so he left that up to us to decide where we wanted to put those carpet mounts in case we'd already settled on a particular carpet set that did already have holes in. Anyway, we've made a judicious decision on where they all go based on what we're doing in terms of carpets. So Scott's job today has been fitting those, and I'll go into a little bit of detail just because this was what I was doing just a minute ago. So I will quickly show you. This is our spot welder, which we've talked about before. And this is a single-sided spot welding gun. For when you only have access to one side of a panel, or you need to weld on captive nuts, or you want to weld pulling pins or something to a panel, you use one of these, which is a single-sided weld gun. Basically, instead of clamping two pieces of metal together with the C gun, that one, like that, instead of clamping two things together between those tongs, oh, that's heavy, you use this and you just push from one side and earth the piece of metal, push from one side and weld the two pieces together simply by hand pressure and the current application through there. The problem with using a single-sided process like that is it's quite often difficult to get suitable penetration of the weld. So it's always best to do a weld test, which we've done using a piece of steel the same thickness as the floor with the same preparation on the surface, same preparation on these. These were the mounts. This was a spare one. They've all been glass bead blasted to clean them up and make sure they're completely clean first, and then lightly sanded. And then these were single-side spot welded using that gun together. We've done 2 tests on that, just to make doubly sure. And as you can see, in both cases, it's torn the base metal out. It's torn the base metal out from there. So that's a successful weld. We're happy with that. As long as those weld nuggets have torn out, then the carpet mounts are not going to fall off and your carpets aren't going to come out. So that was a test done there just to make sure that we were happy with that. That's the stage we're at first. Is going to be some basic prep work and also sourcing bits of replacement bright work for the missing parts, and also trial fitting the bright work that we have got that is usable, just generally making sure that's all good. The next phase after that, which should be doing early next week, will be the body tub itself, not the bonnet, but the body tub itself will be arranged on the rotisserie. It will be glass grit blasted, crushed glass blasted underneath, our normal process underneath, and any areas where there was new metal on the inside of the tub, just not any of the outer surfaces, probably the gutters and window apertures as well. We'll crushed glass blast and then zinc metal spray. I'll zinc metal spray the window apertures, the gutters, and the entire underside of the body tub will all be zinc metal sprayed. Then we can proceed with all the rest, and then the blasted areas inside the car, will also be anti-corrosion epoxy primed, and then we can proceed with the rest of the prep work on the shell, and then continue with bright work fitting, all that side of things. So that's where we're at with the E-Type project, and I think moving on from there, the other area is into Itchville. We'll head over to where the Jensen is, and Steve's busily sanding. We're actually getting through this fairly well now. Steve's doing the final shaping on the areas where we've done door into body blends. Again, for the uninitiated people coming to this video for the first time this week, I doubt there'll be many people coming to it for the first time, but people who are, this car, the first thing to say is that this car is a book. A mould is being taken from this, so there's quite a lot of this is just made of filler. There's quite a lot of the side panels, and particularly the rear quarter panels, just by Steve's left arm now, are literally made of filler. And that's just to give us a shape, because we've widened the quarter panels on the car, we've changed the shape of quite a few areas, reasonably subtly. The widening's more dramatic, but quite a lot of it's reasonably subtle. But where we've changed the shape of it, a lot of that's been done in filler, or by just fairly crudely cutting the fiberglass, pulling it, and then re-fiberglassing it in place. So that's not bodywork that we're going to be painting. Well, we probably are going to be painting it, but only in as much as being able to get a mould off it. It won't be the final part going on the car. Other work that's been done, I'll dance around here so I can gesticulate in the right direction, but other work that's been done this week is continuing with the shaping of the rear panel. Those who know a CV8 would know that normally it had mountings for 3 Lucas type lights here, which it now doesn't. That's all gone. We scanned that, we mentioned it last week, we scanned that area. Using that scan data, we're going to machine aluminium sections that are going to sit here as plinths for replacement lights of a different type. They'll still be in keeping with the type of car, with very similar theme to the originals, but mean that we can do away with those little flat plinths where those Lucas round lights sat, which are incredibly difficult and time consuming to correctly prep for paint and not look a mess. And if you look at a production car, they generally do look a bit busy and a bit messy in that area. So doing that as an aluminium machine piece to carry the light eliminates the prep detail from all of that area there. It means that aluminium section covers, will carry all of that detail on a part that's machined and then anodized. So there's no prep, no paint, no nothing to worry about on that. There'll be basically a machined anodized section here carrying the lights, a machined anodized section there carrying the lights, and then a little anodized section joining the two across the back to keep that continuity all the way across the back of the car. That's going to look really smart when that's done. So that's where we're at with that. The doors have been on and off a lot. We've been battling with Jensen hinges quite a lot, but they're pretty much sorted now. The panel gaps are getting there. They're not quite there yet, but they're getting pretty close. We were just, guys is pretty happy with the door that side now. This side is still roughed out in terms of the filler work on the door, but the gaps are getting somewhere near. They're all within the realms of some block sanding and finer adjustments, basically. So then, a short while ago, Steve and Gaz were putting the bonnet back on to check door to bonnet alignment and start fiddling around with that. There's so many adjustments on that. There's quite a lot of work to do there. We've got to put some extra buffers in on that as well to keep the alignments all accurate. So that's another little job. So the other thing we've done there is had a little bit of a brainstorm on the bonnet catch arrangement on this. The bonnet on these pivots at the back on a pair of extremely crude hinges that we're going to copy because they do the job perfectly well. We'll do them in stainless steel instead of mild steel, but basically a pair of stainless steel plate hinges, extremely simple. They just pivot on a pin. They're great, they're fine, we're not going to change anything there. But the bonnet catch arrangement on these was originally tied into the steel frame that supported the underside of the bonnet. We're doing away with that because the bonnet's being made in carbon fibre. There's absolutely no need to have that steel frame because we can put hollow sections into the back mould for the carbon, which will stiffen the bonnet sufficiently. We don't need the steel frame anymore, and the steel frame wasn't that stiff to start with. But the steel frame did carry the front latch arrangement, which is a lever which basically operates a pair of shot bolts, which is accessed through the thing that looks like a fuel filler flap in the front of the bonnet. And it's actually quite a characteristic of these cars, and we don't want to lose that because it is quite a CV8 thing. You know, a CV8 has that funny flap that you open with the key that has a big lever in it to open the bonnet. We don't want to get rid of that. And actually the mechanism for latching the bonnet down is very strong, and it carries the latching load right out to the sides to keep the front of the bonnet quite stable under air loadings. So actually it's quite a neat setup, other than the fact that it's all made of mild steel, it's all rusty, it's all grotty, and it does look a bit like it was made from scrap that was found on the floor. So what we're going to do is remake that in a combination. I think current brainstorm in my head is a mixture of billet aluminium and some bronze bushings probably, and some stainless steel moving parts. I imagine the next thing on the comments list is going to be a whole lot of people lecturing me about aluminium and stainless steel. I'm aware of all that. The aluminium will be anodized, everything will be finished, so there's no corrosion between the two materials. But we will have a stainless steel shot bolt arrangement, I think, with a stainless steel handle to pretty much replicate the original from the visual parts, but then underneath we'll use the carbon to advantage, and we'll bolt that mechanism into threaded inserts. There'll probably be 8 threaded inserts as part of the back reinforcer on the bonnet, which will be part of the carbon part. And then we'll probably, I think, my current thinking is a billet aluminium section across to carry the stainless steel parts and the moving parts, and also that also will carry the adjusting buffers for the front closing height of the bonnet, and also the safety catch for the bonnet. So we've got a bit of design work there to do. So I think next week there'll be another announcement next week, which I'll let you, I'm going to hold fire on saying anything, but there will be another announcement next week in the video, and that will tie into probably a bit of design work going on here, but we'll save that one for next week as a bit of a thing to hold on for. But I think that's pretty much where we're at on the CV8 at the moment. I think that rounds up everything this side. There's been bits of other stuff going on, but I think that rounds up pretty much where we're at this side of things. So I think for this week, that's probably about all, folks, and we'll see you again next week.